Hey guys, this is Coach Lowe, and we're going to talk a little bit about Chapter 9, Section 6, Contextual Geometry, Proportional Parts and Parallel Lines. All right, so first let's write down a theorem. This is Theorem 9.8, and if we have 3 or more parallel lines intersect 2 transversals, the lines divide the transversals proportionally. All right, so I have 3 parallel lines, or you could have more than 3. So do you remember how to mark lines parallel to each other? They have little arrow heads on them, don't they? So I have 3 parallel lines, and they intersect 2 transversals. So let me get my transversals in here. All right, transversals do not have to be going the same direction at all. So this is transversal T and transversal V. And this is L, M, and N. And we'll call these intersection points A, B, C, and D, E, F. All right. So if L, M, and N are parallel to each other, and remember we talked about this before, if L is parallel to M, M is parallel to N, then L is parallel to N. They're all parallel to each other. So if I have 3 or more parallel lines intersecting 2 transversals, the lines divide the transversals proportionally. So these lines are dividing the transversals proportionally, which means AB over BC is proportional to, is equal to DE over EF. So it doesn't mean that these guys are equal in measure, it just means that they're proportional. So AB over BC is equal to DE over EF, meaning we'll get the same ratio spit out as we figure out what these numbers are or what goes in those spots. All right, so let's check this out. We're going to talk about proportional here, and then we'll look at some numbers in just a second. So I see that these 3 lines are parallel. So TX over XZ, so this section over this section is equal to something over this section. So what's missing that matches? Yeah, WY. All right. Let's look at number 2. WY over WA. So now I have little piece to big piece is equal to TX, little piece, and I need big piece. So hopefully you see how that matches. I think it's nice to go ahead and draw the figure out, and that way you could kind of mark it up like I'm marking it up. All right, let's look at the next one. So YA to WY, XZ to what's missing? Yeah, TX or XT. All right, so pause the video and finish up on those next 3. All right, so now that we're back, WA is the whole thing is to something. So I have that. And the other side, TZ is to TX. So this tells me what's missing. So WY is the missing piece. All right, next one. AY is to something as XZ is to TX. So you know what's missing there. And then TZ, which is the whole thing on the left side. So TZ is to something as WA is to WY. Now you know the missing piece. So if you don't understand that or if something doesn't make sense on that, put a little star by this and make sure that you ask me in class. Okay? All right, let's look at the next ones. All right. Okay, so let's check this out. And I'm going to go ahead and give you theorem 9.9 here. Theorem 9.9 says if 3 or more parallel lines cut off congruent segments on one transversal, they cut off congruent segments on every transversal. So that means if you see markings of sections that are congruent, then the other section is also congruent. So like this number 11 right here. This section's 30, that section's 30, this one is 30, that has to be 30, which means this whole thing has to be, yeah, 60. All right, so theorem 9.9. 3 or more parallel lines cut off congruent, so that means equal in measure, right? Congruent segments of one transversal they cut off congruent segments on every transversal. So that means if this is 30, that's 30. If this had been 25, that would be 25. That's what that means. It doesn't mean they're congruent going across. It just means down the transversal, they're congruent. All right. So hopefully that makes sense as well. Okay, so let's look at number 10. This one kind of deals with it too, and it's kind of funky. All right. So I have parallel lines going this way, transversal going this way. So I have 8 and 8 here. So this section is 8, this section is 8. That means this section is 18. That one has to be 18. That means this whole thing has to be 26. All right. So hopefully that makes sense. So 8 over 18 equals 8 over x on that one. All right, number 12. Let's look at this one. So 4 is to 16 as 5 is to x. All right, so cross multiplying, and I would reduce this one first. 1/4 equals 5x, and quick to solve now because 1 times x is x, and 4 times 5 is 20, so x is 20. All right, let's keep going. You could pause the video if you want to and kind of try these out by yourself. That would probably be a pretty good idea. All right, so parallel lines cut by transversals. So I can set up proportions. 9 over 3 equals 5 over, I'm not going to use x because x is this whole thing. I'll use y. I have to find this little piece before I can find the whole thing because the whole thing would be these two added together. So again, reducing first, 1/3 equals 5y, or y is 15, which makes x 20 because 5 plus 15 is 20. So next to number 13, write x equals 20. Make sure you show that to me when you come to class also. All right, let's look at this one. 20 over 60 equals x over something. Uh-oh, this is a problem. Because this whole thing is 88, how much is this piece right here? Well, it would be 88 minus whatever we find right here, but we don't know that. So we just have to write 88 minus x. All right, let's for sure reduce this before we start. So this is 1/3, just canceling out the zeros and then dividing by 2. 1/3 equals x over 88 minus x. So cross multiplying, 3x equals 88 minus x, and then let's add x to both sides. So 4x equals 88, or x is 22. So when x is 22, we can also find this little piece. It would be 66. They didn't ask for that, but that's all we needed to find was that little piece right there. All right, last one. 7 is to 21 as 5 is to, same situation, right? I don't know this little piece, but this little piece would be x minus 5, taking out that little piece. All right, reducing again before we cross multiply. So x minus 5 times 1 is just x minus 5, and that's equal to 15. Adding 5 to both sides, x is 20. All right. If there's anything that you don't understand that doesn't make sense, then please write yourself a note or write me a note, or you can send me a message on Remind 101. Hey, I didn't understand this example, Coach Lowe, and I'll hit that before we start class. But just let me know. All right. So make sure you show me the information that I asked you for, and I will see you guys soon. This is Coach Lowe, and I'm out.